So Jeff, could you tell me a little bit about the variability in weather patterns and the cycles? So if you can explain a little bit more about what is El Nino, what is La Nina, what's the frequency, what are the patterns behind them?
Yeah, it really affects the weather of Queensland, particularly southern Queensland. And a good way to look at it, I suppose, is to look at what's happened to the beaches over the last 150 years. There's Coolangatta got wrecked, the vessel Coolangatta got wrecked at Coolangatta, hence the name of Coolangatta, in 1846 or 47, I think. Yep. And they were able to walk from Coolangatta to Amity Point.
Really?
Yeah, so there was no jumping pin bar, there's plenty of sand.
Yeah.
In the 1890s, with a lot of tropical cyclones, an immense number of tropical cyclones, 1880s, 1890s,
yeah.
jumping pin bar broke through, you know, just a constant attack from the ocean with plenty of cyclones.
Mm.
Then things went quiet until the 1930s, and beach erosion came back in full force in the 1930s during a prolonged La Nina period, 1931, yeah. 36, 37, 38.
So if you go a step back, what's the difference there between La Nina and El Nino?
Yeah, well, La Nina, all the cyclones come towards Australia,
yeah.
remember we mentioned before, and El Nino, they all come in and go away, don't
okay.
they?
Yep.
And so you get attacked a lot more during La Nina by tropical cyclones.
Okay. Yep.
And after 1930s, they were quiet, and then the 50s, 60s and 70s, we just had an enormous number of tropical cyclones affected the east coast of Australia.
Yep.
And that was in a dominant La Nina period.
Yep.
They have a name for it nowadays. They call it the Interdecadal Pacific Oscillation, the IPO.
Okay. Yep.
And for instance, if it's a negative IPO, you get lots of La Ninas.
Yeah.
If it's a positive, you get lots of El Ninos.
Yeah.
Unfortunately, the sign convention is opposite to the Southern Oscillation Index, which is a bit confusing. But anyway, that's the way it works. And if you look at the paleontology data, it's a very robust feature. It shows up in the coral studies they do right through the Pacific, back 1,000 years. In fact, it's the reason why the Polynesians were able to get over to Easter Island, because they came in a prolonged El Nino period when there's lots of westerlies along the equator. And so it really affects the whole global climate.
Yeah.
And the period from 77 to 2006 or 7, or 2005 probably, we had dominated by El Ninos.
Yeah.
And people were worried about running out of water, running about never going to rain again, all those sort of things. Yeah. And we flipped over to the La Nina dominated period. Now we're starting to get cyclones.
And can you predict that? Is the time between a La Nina and an El Nino equal?
You just need a lot more of them when you're in the negative phase of the IPO. For instance, in that you get them both, but in that period from 49 or 48 to 76, La Nina just dominated. You know.
Yeah.
And since then, up until about the early 2000s, El Nino dominated. For instance, through the 1990s, we just got one El Nino after another.
Yeah, wow.
And you just can't, we don't know enough about them. The models can't predict them. The models have no skill in predicting whether you're going to get a head towards a more La Nina or El Nino climate. Yeah. So they can't help us there.
Yeah.
But so what we have to assume is that it'll just keep on continuing on. And so we're no worse off because we don't know, except they tend to last anything between 15 to 30 years.
Yeah.
So all things being equal, we're probably in for a fairly prolonged period of having more La Ninas and El Ninos,
which
means more storms for us, more cyclones.
Yeah.